Hello everyone and welcome back. So in this video we're going to look at how to find the traces of a plane or for a plane containing our hexagonal lamina here, and this time we're going to use method 2, which is our trace line or waterline approach for finding it. So this question here, I specifically designed it so that there's a couple of little things you have to think about when it comes to selecting where you take your horizontal slice. So if we look at our question here, there's our elevation, our plan, there is our 3D of it, and we're going to take a horizontal slice. Now in this case here, I'm going to take it from my point here, going across to this point here, 5 and 2 being horizontally across from each other, which makes life quite easy for us insofar as that we have 5 and 2 already, so we don't have to go and find any points. So it's certainly the easiest way to go about doing it. And you can see the idea being that that horizontal line there in our plan view is going to be parallel with the horizontal trace. So there's 2 and 5 like that. Now just a couple of things just to note about with this. One is that if I was to take a slice slightly up higher here, well, that would give me a point somewhere between 5 and 4, which I could bring down and find that point between 5 and 4 there. That's perfect, no problem there. But if we take it across and say where it hits the point of the line 3 and 2, well, because it's a vertical line here and it's a vertical line in plan, when we bring it down, we wouldn't be able to find where it crosses in the middle. We'd actually have to go to an end view and find where it hits the end view, then bring it down and across to find where that would be located. So, and the same thing applies if we did it in our below here like this. If we took a horizontal line across, finding where it hits between 1 and 2 is no problem, but where it would hit between 5 and 6, because it's vertical, we wouldn't be able to find it in our plan view. So that's why I took this line here. And a second thing to note is that, well, this is a horizontal line that I've drawn on the surface. You actually have a horizontal line already, 4 and 3 and 6 and 1. And you can see our trace line here, which is parallel with the horizontal trace, is actually parallel with 4 and 3. So we actually had that angle. So if you were kind of, I suppose, astute enough, you might realize that you don't actually need to do your strike line or your trace line at all. You actually have the angle because 4 and 3 and 6 and 1 in this case are horizontal in elevation. They will actually be parallel with your trace and plan. So just, it's a question which maybe might just look a little bit different to kind of your typical question. So let's see then, part 2 is knowing the angle of our horizontal trace, we need to find a point on it. So we extend on an existing edge the way we would for method 1. So 4 and 5 is the edge I'm going to extend. They're down to our plan view, extended like that. And that's our point where we get our sliding set square set to 5 and 2, or again 4 and 3, 6 and 1, all parallel. And that gives us the horizontal trace there like that. And for method 2 then, the way we find our vertical trace is we can pick any point on our lamina in elevation, and we're going to draw basically a level line from that. So let's see it here. In this case here, I'm going to pick maybe the point 4. So there from 4, I'm going to draw a line parallel on our surface, parallel to our horizontal trace. Because the horizontal trace is horizontal, our line will look horizontal in elevation. In plan view, it will look parallel to the horizontal trace. So there's 4 and 3. There is our line parallel. And you can see it is actually just an extension there because 4 and 3 was already parallel with the horizontal trace. That won't always be the case, but in this case here, it happens to be that way. So where that line parallel with the trace hits the back wall, that's our XY line in plan view, we project it up, and then we just draw our horizontal line in our elevation, giving us our point on the vertical trace. And there's our VT like that. And that's the question complete.